Hello. What if I told you that you can use the same tool that is used to deploy the Netflix service today to deploy and orchestrate your container deployments? Well, good news, you can. Today I'm here to talk to you about Spinnaker. Spinnaker is the continuous delivery platform that is being used at Netflix to deploy the Netflix service. My name is Tomas Lin. I work for the delivery engineering tools team at Netflix. And this is Lars. He works on the Spinnaker team at Google. The Netflix service. The Netflix service is available in over 190 countries. We have over 93 million subscribers. Every day, over 125 million hours of television, movies, and even comedy specials are streamed through Netflix. The Netflix footprint is enormous. In fact, we run in over 100,000 Amazon EC2 instances. If you look at the Netflix service itself, you'll notice that it's deployed as a series of microservices. This is a tool called Visceral. It's open source. And what you're seeing here is requests coming into the Netflix service, and all those big white dots represent a service that is being hit within the Netflix ecosystem. Each of these services also represents a team that manages that service. There's no centralized DevOps team at Netflix, so there's not one team that goes around and deploys everything. Each team is responsible for the tools that they choose to deploy, manage, and build their services. So what the Spinnaker tool tries to do is take the deployment processes available to each of these teams and allow them to build fairly flexible, fairly easy to modify deployment pipelines. So here's an example of a deployment pipeline. We designed deployment pipelines in Spinnaker to be easy to edit. So as your team's deployment process changes and grows, it should be easy to just come in and add new stages, remove new stages, and move stages into other pipelines. Here's an example of me just coming in and adding a new pipeline stage. So as you can see, adding a new stage in Spinnaker really is just choosing the type of the stage that is available, and then any information that I need is available to me contextually. So here you can see adding a Jenkins job. I just pick the job. I have all the parameters that I can set. Pipelines can grow quite large. The nice thing about Spinnaker is that it gives you that nice overall view of kind of the end-to-end process, your deployment process. This is a real pipeline, and what you're seeing here is actually over maybe 175 Jenkins stages that get executed. So what Spinnaker does is it gives you that nice kind of bird's eye view of all the steps that are needed. There are a lot of really cool things built in, so you can, for example, turn off a branch of this execution, turn off particular stages, restart the stages in the execution, and so forth. Now, even though this execution is super complex and big and complicated, all of that process is really encapsulated into just one pipeline, right? So in order for me as a user to use this pipeline, I don't have to have an intimate understanding of all the steps that are needed to orchestrate this. As far as I'm concerned, I'm just coming in and running the deploy to prod pipeline. So I come into Spinnaker, I click on run deploy to prod, I get this nice little dialog box that allows me to then hide all the complexity of that orchestration behind a simple dialog box. Most users don't even see this dialog box because a lot of this automation gets triggered automatically through either somebody checking in code through a Git commit or a Jenkins stage. Now, Spinnaker has been widely used within Netflix. In fact, we deploy to more than 99% of all the services in Netflix are deployed with Spinnaker. Last month alone, we ran a little bit north of 100,000 pipelines, and that translates to about 6 million manual tasks that are needed to do. We are very excited about Spinnaker because we believe that Spinnaker represents the state of the art in multi-cloud deployment and managing deployment processes. So we open sourced Spinnaker in November of 2015, and we're really excited to have a lot of community partners that really came in and collaborated with their own stages and their own cloud providers. Google was one of the first companies to come in and help us with the open sourcing of Spinnaker. So I'll let Lars talk to you about why Google was interested in Spinnaker.
Yep, thanks, Tomas. So like Tomas has said, Google's been involved in Spinnaker for a long time now. And let me motivate a little bit why Google's investing so heavily in Spinnaker. And it really comes down to the fact that Netflix and Spinnaker's core tenets align really closely with those of Google. What I mean is that Google's been a very early adopter of the continuous delivery and the mutable infrastructure paradigms, and these are really what Spinnaker is built on. Most of the tooling you'll find inside of Google is very expert level and self-service, meaning that at the cost of complexity, you have a very fine-grained and high level of control you get into the application you're managing. And this is really what you see inside of Spinnaker. So given the opportunity to contribute to open source software that aligns with these tenets and also helps foster building an open cloud is really a big win for Google. It's worth mentioning I'm one of 6 engineers on the Google New York Spinnaker team. We're all working full-time on Spinnaker. We have a full-time manager, half of a project manager, and there's a couple of teams, internal and external, at Google using Spinnaker, like Waze, for example. They manage all their active cloud deployments across Amazon and Google's clouds. So in 2014, after Netflix started the project, a few months later, one engineer, our current tech lead, joined in and helped, before it was open source, hoist out a lot of the interfaces and make Spinnaker more amenable to a multi-provider model. And in doing so, he added support for the Google Compute Engine provider. We've added support for Kubernetes. Netflix has added support for Titus. Other providers have been added by other community members. But for the purpose of today's talk, the interesting providers are Kubernetes and Titus because they focus entirely on container-based workflows.
So one thing to mention here is that whenever we talk about multi-cloud deployment, we're not really saying you can only deploy to one cloud. What we're saying is within the Spinnaker system, we enable you to have more than one cloud enabled. In the case of Waze, they deploy to the Google Compute Engine and Amazon Web Services. In the case of Netflix, we deploy to Amazon Web Services and Titus. All the work being deployed to containers is being done on Titus, and all the work being deployed to VMs is done to Amazon Web Services. And Titus itself is deployed by a Spinnaker onto the Amazon Web Services. So like I said, Titus is hosted on AWS. It is built Netflix scale, talks really well to all the tools and systems in the Netflix infrastructure. So if you're familiar with tools like Eureka or Atlas, Titus was built to have first-class support for this. Titus also is very aware of all the components of the Amazon Web Service that it sits on top, so it's able to use security constructs such as IAM profiles and security groups. You can also mount things like EFS volumes onto Titus itself. And you also have access to resources such as GPUs that are managed directly and mapped to the underlying implementation running on AWS. Titus is able to run both batch jobs and service jobs, so long-running jobs and one-time jobs, and they're very successful. Last week alone, they ran over 800,000 containers just in a week.
If you're not familiar with Kubernetes, it's a system built and designed by Google. It's a redesign of an internal system called Borg. Borg is a system inside of Google that runs and schedules pretty much all of Google's services, which also run in containers. So that's Google Search, Calendar, Gmail, you name it. But counter to Borg, Kubernetes also runs outside of Google. And that's on public clouds, on private clouds. You can get it running on a bunch of Raspberry Pi nodes if you wanted to. It's worth mentioning that Google has a hosted Kubernetes option called GKE that makes it really easy to get up and running with a production Kubernetes cluster. A lot of what Kubernetes does is it simplifies the operational experience that you'd expect to run into when you're scheduling and running your own containers. So it has built-in secret sharing, service discovery, auto-healing, auto-scaling, all these things that might cause headaches if you're trying to orchestrate and deploy to containers yourself. So let's take a look at Spinnaker. Before we get to the container-specific bits, let's take a look at Spinnaker at a high level. Right here, so when you open up Spinnaker, you're greeted with this cluster screen right here. And there's a lot of information here. So let's take it and break it down from the bottom up. Those green squares you see up there, each of those represents in Spinnaker what's called an instance. And an instance is an abstraction in Spinnaker, which in Kubernetes maps to a pod. That's just a group of co-located containers that together form an application. Those instances in Spinnaker are grouped together into server groups. And again, a server group in Spinnaker is just an abstraction. In Kubernetes, that's a replica set. In Amazon, that's an ASG. In GC, that's a managed instance group. And the important thing to note is that every single instance in that server group is running the same exact application and the same exact configuration. Spinnaker groups these further into clusters. We have 2 clusters up there, demo dev and demo prod, if you can read that. And a cluster is a group of replicated, versioned server groups. And typically, you'll have at most serving traffic at a time, at most 1 serving traffic at a time, just like you see up there. So for example, here we can click on the server group to get some more details. We see the Docker image that it's running. If you're familiar with Kubernetes, you'll recognize this right here as the resource YAML that's backing the Kubernetes resource. You can post this to kubectl if you wanted to recreate this. We have links into the Kubernetes UI, for example, that show some other information that surface from the perspective of the Kubernetes cluster. And then the Spinnaker UI also offers a number of remedial tooltips that you can use to manage things in case they go wrong. So you can click on the server group and say, I want to roll back to a prior known good version. Or you can click on an instance, for example, and say you want to terminate it if you think it's misbehaving, and have Kubernetes reschedule it for you. And what Spinnaker is doing here is it's talking to a shared cloud provider abstraction layer and orchestrating a series of steps against it to get to some desired end result. So this leaves the question, how do you actually use Spinnaker to deploy a new version of your application? And of course, you can go through the UI and click through it and update your Docker container, but we want to automate this. So let's jump ahead here. There's many ways to do this in Spinnaker. The canonical example is the promotion pipeline. We're going to go through how these run, and there's 3 core steps to it. So the first thing you want to do is you'd want to deploy your Docker container to a dev environment. And what this lets you do is confidently validate that whatever you've built actually behaves the way you want it to. And that's the second step. Once you've validated and you're confident that you can promote to production, that's what you do. You take that same Docker image you validated and redeploy it inside of a production cluster. There's many ways to get a Docker container into Spinnaker. One way is Spinnaker can bake the Docker container for you. You can point it at a Git repo where you have a Docker file, tell it how to tag the container, and have it do the rest. Or for the purpose of this demo here, we're going to use an external Docker bakery. So same exact cluster screen we were looking at before. We're going to click on the server group and now select this load balancer tooltip on the production cluster. It has a publicly facing IP, so let's take a look at what we're serving. It says hello DevOps with a blue background. For the purpose of this talk here, we're going to try and get that background color from blue to green. So we navigate back to the Pipelines tab here, and what we'll see is the same 3 steps that we mentioned earlier. So we deploy to dev, we validate, and then finally, when we're ready, we promote to prod. So before we can do this, though, we need a Docker container that we can push through these pipelines. So we'll open up our text editor, and we're going to open up that application that we were looking at before. So we change the color from blue to green. We commit that change. And once that's ready, we can push that upstream and have our Docker container builder pick up on that change. For today's talk, we're going to be using Google's container builder. It assumes you have a Git repo that you can point it at. So we've pushed our change. We'll open up our container builder. And it has a lot of nice features. We're going to focus on the basics here. You point it at a Git repo, like I said. You say anytime any branch changes with a commit incoming, you build using this Docker file. What we're doing here is we're tagging this with the branch name and the commit SHA. It's important here to generate a unique Docker tag, because if you keep using the same tag over and over again, you'll very quickly lose sight of what's running in your cluster. So in this case, the branch name and the commit SHA gives us a reasonable degree of traceability. So this build should have been kicked off by now. We go into our build history, and we see the build's already running. And the one thing to look at here is the image ID. It's that commit SHA. In this case, it starts with the character 16CB. We're just going to use that for a verification that we're actually pushing the right image through these pipelines. So while it's running in the background, let's open up that deploy to dev pipeline. And what we've configured here is we've said we're looking at this one registry, and anytime a change comes in on the master branch, take that Docker image and put it into this pipeline's execution context. So we're going to deploy that image. And what we've done is we've said, take that image from the execution context and use that as my Docker container to deploy. You can configure pretty much anything in this UI here that you could with that regular Kubernetes resource file. But if you don't like clicking through the UI, you can also import stuff that you already have running in your cluster. So here I'm taking a replica set that I've already deployed. And pretty much, again, anything that I could have configured in that resource file is already imported for you here into the Spinnaker UI. So the Docker builds usually take a little while. So we're going to skip ahead until the build completes. And you see the deploy to dev pipeline just finished. So we're going to navigate over to the replica set that it deployed for us. We see all 10 of our pods are healthy. And if you can read it, it says 16CB on that Docker container right there. So our validation's pending approval. There's all sorts of validation you can do inside of Spinnaker. We're going to keep it simple. We've templated a link to this deployment UI right here. And we're going to pretend that we're looking at the metrics and say that they look OK for us. So we continue. Once this finishes, our promotion pipeline needs to do two things. So one, it needs to find that Docker image that we deployed in the developer environment in the first pipeline, which it did right here. We can see that we found Docker image 16CB, and that matches exactly what that trigger found. And then the next step is to take that image and deploy it much in the way we did before, but this time deploy it into the production cluster, which is what we did right here. We can take a look at what it deployed. And again, we'll navigate over to the load balancer and open up that publicly facing IP. And we can see that the background color is now green. So we talk a lot about the fact that there's more to continuous delivery than just orchestration, but the orchestration does get a little interesting in some of Spinnaker's deployment strategies, especially in the case of Kubernetes, where we can make use of the Kubernetes deployment API to handle the updates for us. And just like you can configure in that deployment API resource, you can say, I want to use a rolling update with these parameters. You can configure in the Spinnaker UI, and then have Spinnaker hand off the work to Kubernetes to actually update your replica set. More canonically, and for every cloud provider, you can use the Spinnaker red-black, or more commonly known as the blue-green strategy to do your updates. And if you're not familiar with it, what it does is instead of killing instances one by one and spinning up new ones, it spins up a whole new server group, waits for it to be healthy, and then once it is, switches traffic over from the old server group to the new server group, leaving you with something like this, with the old server group sitting around until you want to kill it off for very fast rollbacks in case something goes wrong. And there's benefits to both of those approaches, but they also have some fallbacks. So we've come up with this rolling red-black strategy, which we're implementing, which allows you to define a series of target percentages in your rollout. And if you're stuck with a linear rollout strategy and you're very confident after rolling out to 10% of your users, and it's taken 3 hours, you shouldn't have to wait another 27 hours to roll out to the next 90%. So instead, you can say, roll out faster and faster as I get more confident, and also validate at every stage that what's running inside of my cluster meets whatever criteria you put on it. Finally, because we chunk the rollout, we also lower the pressure you put on downstream dependencies as you roll out. If you have a shared cache that you write to on startup, or if you contact service discovery when you come up, red-black deployment might take those out if you bring up too many instances at once. And like you'll see here, because we keep around a pool of instances as we roll out, by progressively disabling more instances in the old server group and spinning up more instances in the new server group, we again have that pool of instances ready to roll back at any time and do that very quickly.
Thanks, Lars. That looks great. I'm here to talk to you about the round job stage in Spinnaker. So, like I said before, Spinnaker's pipelines are made out of many stages. And the advantage here of the round job stage is that we just run a Docker container as part of our deployment process. So I have a pipeline here. What we're doing here is we're doing a deployment to Amazon Web Services, and afterwards we just want to run a set of smoke tests. Now, before this stage became available, we would normally run this as either a Jenkins job or a script job. However, now that we have the power of containers, we can run this set of smoke tests as a Jenkins job. And there's several advantages here, right? So I can test this locally, and if it works, I can then just push it up to the Docker registry, and then my code for the stage itself is just going to be changed right away. I can take advantages of kind of the flexible resource management. So in case my smoke tests take twice as much memory to run, I can just simply come into the stage and change, the memory allocation provided here. You can also see here that I take advantage of Titus's ability to use security groups from AWS. So I just pick a AWS security group and use it at the bottom. It's worth noting that the run job stage is available to you both in Titus and Kubernetes. So I run this job, and what I see here is links to the Titus execution that was executed. And you can see that I have the ability to drill down deeper and look at the S3 look at the logs of that execution that are updated to S3. Because this set of smoke tests passed, that means the container finished successfully, you can see that the stage is now green, and then I can move on to the next phase. So far we talked to you about kind of the mechanics of getting new containers up and running in the cloud, and maybe even as part of the deployment pipelines. One of the kind of essential design principles of Spinnaker really is to allow you to kind of build deployments that are fairly low risk, that are fairly safe. And this is manifested either in ways of features within kind of the pipeline execution engine, or as separate stages available in Spinnaker. Let me give you an example. Let's say I have a cluster and I have a server group in the cluster that is taking traffic. Now, if the server group goes away, there's nothing serving traffic, there's an outage, right? This is bad. So what Spinnaker allows you to do is set a traffic guard. And what the traffic guard is going to do for you is it's going to protect this last server group taking traffic. So if that traffic guard is enabled and somebody tries to come in and disable this last running server group, Spinnaker is just going to say no. So if you try to run this step manually, you'll see that a traffic guard has been enabled on this last server group, and instead of allowing this step to go through, what Spinnaker is going to do is it's going to protect that resource. If you try to run this as part of a pipeline, your pipeline will fail. So that's one of the several safety features that are built within Spinnaker. And there are many more. And they're available to you right now if you start deploying your containers using Spinnaker. Now, I don't have really a lot of time to go through each and every one of these steps, but I do want to highlight the last two in this list. Automated canary analysis at Netflix is a technique that allows us to look at new code and old code and say, is this good? Like, does pushing this code count any source of regressions? The process that is used here is there's a mathematical model that is used to compare all the metrics that are coming out from the old code and the new code. And if things are okay, the pipeline progresses. If things at any point fail to meet this criteria, then the pipeline is automatically finished. And then the other thing I want to highlight is this practice at Netflix called chaos testing. So in Spinnaker, you can run what we call chaos experiments. So what a chaos experiment does is it does an experiment, it does a test in production, and what it tries to exercise is the fallback behavior. So, for example, I can insert latency into the test automatically and make sure that every time that I run my pipeline, this chaos experiments get exercised. There's a lot more on that blog post, so if you're interested in learning more about Spinnaker and how that Spinnaker enables safety practices in your container deployments, I highly encourage you to check out the blog post. Finally, so far we show you a lot of UI, right? Like a lot of little screens that you're clicking with your hand. But fear not, there is an API in Spinnaker. In fact, one of the design principles of Spinnaker was really to allow you to have this API that allows you to talk to both Spinnaker to get a good view of your cloud state and also to kind of mutate your cloud state, taking in account all the safety features that are available to you. The nice thing about deploying your containers with Spinnaker today is that all the good tools that have been developed in the last 3 years that talk Spinnaker for virtual machines are now available to you for containers. Chaos Monkey, my favorite tool at Netflix. What Chaos Monkey does is you set Chaos Monkey up, it looks at a server group, and then it's just going to go terminate a random instance. Why do we do this? I mean, that seems pretty weird. What Chaos Monkey does is it keeps the developer honest, because if you know that the instances in your server group are going to disappear at any time, you're going to work harder into ensuring that the fallback behavior of your server group works correctly. Chaos Monkey is open source, and version 2 of Chaos Monkey talks directly to Spinnaker. That means that the moment that we added Titus and Kubernetes integration, now Chaos Monkey is able to go in, just look at your Kubernetes pod, and shoot the pods in the head. Terminate the pods, sorry, pardon the metaphor. So I hope this gave you a good taste of what deploying containers with Spinnaker looks like. We're really excited about Spinnaker. We think that it has a lot of very cool safety features. And we encourage you to really check out the Spinnaker website. You can spin it up, try it out, point it at your Kubernetes container. There's a very active Slack community. So if you guys want to join us and have any questions, we're there to help. And in case you're interested in working at either Netflix or Google, please come talk to us. We're very happy to answer any questions that you might have. I'd like to open it up to questions. I do want to point out that Diane over there has a stack of stickers. So if you want Spinnaker stickers, Titus stickers, they're over there. So, and Chaos Monkey stickers. So if you have any questions, we're open to answering right now, or you can just come to the front. Thank you.